Okay, we've got 5 more problems to go, starting with number 11. So we've got the heights of 200 students that have been recorded there. We need to begin by writing down the modal group. Remember that the modal group is the one that occurs the most frequently, and the highest frequency is 74. Do not write down 74, however. The modal group is 170 to 180. So that's the category of data that occurs the most frequently. Calculate an estimate of the mean and standard deviation of the heights. Remember that when you were doing estimates of means and standard deviations from a frequency table, that you need to use the mid-interval values. So we'll go to Stat, Edit, and inside, let's clear these first. Clear, right. So we've got our mid-interval values of 145, 155, 165, 175, 185, 195, and lastly 205. So a total of 7 rows in my table, and I've entered a total of 7 values. I'll put in their corresponding frequencies: 2, 28, 63, 74, 20, 11, and 2. And let's just check that I've got the same number of values in each list. Yes, I do. So now I'm ready then to quit, go into Stat, calculate 1var stats, and I'm going to be using all of the values that I put in list 1 and all of the corresponding frequencies in list 2. And so I can see that my mean, if I round it to 3 significant figures, it'll be 170 centimeters. So my mean is 170 centimeters, and my standard deviation is going to be to 3 sig fig 10.7. Again, centimeters. Now then, the cumulative frequency curve has been drawn for us. That saves us a lot of work. There it is. And, this is interesting. Look, this is one way that actually we could have resolved our issue a couple of questions ago, where I drew that cumulative frequency curve. I think it was of the mackerel, and I didn't know what to do because it started up at 27. Well, this is one solution that they've used, that they started at 0, then they jumped to 140, which was the lower class interval, the lower end of the smallest class interval. It just made this little diagonal line to show that we've actually skipped over a heck of a lot of values here. So that's a clever way of still starting at 0 and yet not having to take up miles and miles of empty graph space. Alright, let's see what it wants us to do with the cumulative frequency curve. It says to write down the median height. So we've got a total of 200 data values. The median will occur at the middle one of 100. You would, of course, use a ruler to draw across, and if we trace it down, we'll see that we arrive at 171 centimeters as the median. Then it wants us to, it tells us that the upper quartile is 177.3. I could confirm this if I wanted by knowing that 3/4 of 200 is 150, so 150 would trace across to here, and if I trace that down, indeed, it does occur right at 177 point something. They say 177.3. Who am I to disagree? Now, the lower quartile I also need for my interquartile range. The lower quartile, or the first quarter, so 1/4 of 200, I'm going 1/4 of the way up, that's at 50. And then trace that down. I should use a ruler, shouldn't I? And that gets me to, it looks like 164 about. So I know that my upper quartile, let's actually write this down. IQR we know is the upper quartile minus the lower quartile. In our case, that's 177.3. And my lower quartile I just figured out was 164. And if you take that difference, you'll get 13.3 centimeters as the interquartile range. And then part E says find the percentage of students with heights less than 165. So 165 is right here. Let's go up to 165 and we'll trace across. And it seems that we arrive at approximately, let's see, there's 5 squares and 20 between them. So each square must represent 4 students. So So if I'm 4 squares up from 40, it's 44, 48, 52, 56. Or if I like 4 below 60. And so this is 56. So I know that 56 of my students have a height of less than 165, but it's asking for the percentage. So that's a ratio, isn't it? 56 students, so 56 out of my 200 students have got a height less than 165. I could do this in the calculator, 56 divided by 200, and then multiply by 100 to convert it into a percent. But another way I could have done this is by recognizing that, look, my bottom is already over 200. Let's just divide the top and the bottom by 2, so it becomes 28 over 100. And I know that a number over 100 is a percent, so 28%. Question number 12. We've got a table with frequency and cumulative frequency. We first need to write down the value of C. Well, we did a question like this earlier on. We know that the cumulative frequency represents the sum of the frequencies so far. So when we only had 16, that was our cumulative frequency. 16 plus 37 is 53. 16 plus 37 plus another 44 gives me a total of 97. And so C, which we know is the sum of 1637 and 44, gets me to a total of 97. On graph paper, I need to draw the cumulative frequency curve, and it tells me to use a very specific scale, where 1 centimeter will represent 0.1 kilograms on the horizontal axis. Well, alright, so I'm going to start mine all the way down at 0, and I need to go all the way to 1.5. That's going to be a total of 15 squares horizontally. So I'll find a new one. Let's move it over so I can write in my scale. And so I'm starting at 0, and I'm going up by 0.1 at a time. I'm only going to write down every 2 of them. And there, I've safely passed 1.5. And you remember that every cumulative frequency curve starts with a point right at 0, 0. Let's see what the other scale was for the vertical axis. I need to go 1 centimeter for each 10 units. And I'm going to get up to a total of 130 units. So I'm going up by tens. Again, let me just go up by 2 squares at a time. So 1 square represents 10. That means 2 squares, or 2 centimeters, represents 20, and so on. 60, 80, 100. Well, I'm lucky, it just squeezes in at 130. And now I need to put in all of my points. Remember that with a cumulative frequency curve, I need to use the right endpoints of each interval. And I'll be using my cumulative frequencies right here. Alright, so I've got 16 and 53 occurring at 0.7 and 0.9. So I'll start with those. So at 0.7, my right endpoint of the first interval, I was at 16. So that's going to be right there. And then 0.9 was the next right endpoint. And at that point I was at 53. So there's 53 right here. Let me look at the next pair. When I reach 1.1, I'm at 97, and my last two are at 120 and 130. So 97, 120, and 130. So at 1.1, I'm at 97. At 1.3, I'm at 120. And at 1.5, I'm at 130. And I'll draw the smoothest curve I can. There we go. And I've drawn my cumulative frequency curve. I'm guessing I'm going to have to use this to do the next parts of the question. Yes, indeed. I need to use the graph to show that the median weight of the fish is 0.95 kilograms. Well, I know that median occurs halfway up. Halfway from 0 to 130 is 65. So let's trace across at 65 with a ruler, of course, and then trace down And yeah, if this was 0.9, I certainly do appear to be right in the middle at 0.95. And so now how do we show our work for this? I think really the line on my graph is going to constitute the necessary work for that 1 point that's been assigned to this question. Part B. The zoo buys all fish whose weights are above the 90th percentile. How many fish does the zoo buy? Alright, the 90th percentile. That means that 90% of my 130 fish. So let's figure out what 0.9 of 130 is. So that's going to be my 117th fish. So that's about here. And if I trace that straight down, I look to be at approximately right in between 1.2 and 1.3. So I guess at about 1.25 is probably where I'm at. So how many fish does... Oh, I've kind of jumped ahead, haven't I? Yeah, that's not actually what it's asking. It said, how many fish does the zoo buy? So the zoo is only buying the fish that are above the 117. Right? 117 fish is the lower 90%. If there's a total of 130 fish, then I subtract those 117 that are in the bottom 90%, and I'm left with just the top 10%, which of course is 13. 10% of 130, the heaviest 10%, is 13 fish. Part I, a pet food company buys all the fish in the lowest quartile. Alright, lowest quartile, that's halfway between the median and the bottom. So 65 and 0 there, midpoint is 32.5. So let's trace across there. Looks to be like I'm at about 0.82 is my... Oh, I didn't label this, did I? My fault. So this is my cumulative frequency. Yes, you can abbreviate it like that if you wish. And I'm dealing with the weights of fish, I think. And this is in kilograms. So weights are in kilograms. And it looks like my weight came down to 0.82. So that is the maximum weight of the fish in order for it still to belong to the lower quartile. Alright, part C. A restaurant buys all fish whose weights are within 10% of the median weight. So within 10% of the median. Well, we know our median is 0.95. If we're within 10% of that, then we are either adding 0.1, that's 10% of 0.95, or we are subtracting, so plus or minus 10% of its own amount. So this is my 10%. So I'm adding or subtracting 10% of the amount. Let's see what I get. 0.95 plus 10% or 0.1 of 0.95. And so 10% above 0.95 is 1.045. And so it says first, calculate the minimum and maximum weights. Well, the max weight, I can see, is 1.045 kilos. And the minimum weight is going to be 0.95 minus 10% of that amount. So minus 10% or 0.1 of the 0.95. That gives us 0.855 kilograms. So that's the minimum weight. It says use your graph to determine how many fish will be bought by the restaurant. So we're going to figure out how many fish we have in between 1.045 and 0.855. So let me draw a couple of lines up from those amounts. 0.855 is right about here, and that comes across to be at about, I don't know, it looks to be at about 42 maybe. Kind of pretty rough, I know. So hopefully with a ruler and a bit more care, I could be more accurate within IB's threshold margin of error that they provide, and 1.045, which is almost exactly in between 1 and 1.1, will be the other one. If I trace that one across, I look to be at approximately 88. And so I don't want to get any of these lowest 42 fish because they're less than 10%. Sorry, they are less than 10% less than the mean. Neither do I want any fish above 88 because they are more than 10% above the mean. So I'm just looking for all of these fish in between the 42nd fish and the 88th fish. So if I take the difference between 88 and 42, that will show me how many fish I bought, and I'll end up with 46 fish. Alright, question number 12. Oh, whoops, sorry, we're already on number 13. We'll do some normal distribution questions. Alright, so here's the first one. Scores on a test, they're normally distributed. We got a mean of 68 and a standard deviation of 8. We need to find the probability that a student scored at least 75 on the test. Let me draw a quick diagram of the situation. So here's our normal curve, and we've got our mean in the middle at 68, and we know that we're going up by standard deviations of 8 on each side. So I don't actually really need to draw this, but it doesn't hurt, just to give me a picture of what's happening. So I want to find out the probability that a student scored at least 75. That means 75 or above. And so we can go to our calculator. Because we're looking for a probability, we want to take the normal CDF. Our lower bound, our left-hand edge of the shaded region, is 75. Our upper bound is going to be positive infinity. This is the best that our calculator can do. And then our mean is 68, and our standard deviation is 8. You'll find normal CDF in second vars. There's normal CDF. And let's put in these values, 75, and then your E, which represents times 10. Oh, sorry, made a mistake. I pressed enter when I should have pressed comma. Let's start again. Distribution, normal CDF, and I've got a lower bound of 75, comma, an upper bound of 1 times 10 to the power of, that's that second comma for the E, 99. That's basically like a million except with 99 zeros on it. It's the biggest number your calculator can handle, close to positive infinity. And 68 is the mean and 8 is the standard deviation. Tells us that the probability is, if I round to 3 significant figures, 0.191. And if it had wanted it as a percent, or if you wanted to express it as a percent, then sure, you can move the decimal over 2 places, 19.1%. Alright, what's the probability of being between 65 and 72? So I'll just change color so you can see what I'm dealing with. Between 65 and 72, we're looking for this region right here. And so again, we're going to use the normal CDF. And you'll notice that I'm writing down normal CDF as a way of showing my work. So my lower bound is 65, my upper bound is 72, my mean and my standard deviation remain the same. So, here we go. Normal CDF from 65 to 72 with a mean of 68 and a standard deviation of 8. Tells me that the probability is 0.338 if I round to 3 significant figures. And of course we can express that as a percent, 33.8%. Alright, the students who achieve the top 15% of the scores, they have given you the percentage this time, so this is going to be a time at which we use the inverse norm. I'm going to draw a quick diagram of the situation again so you can visualize it. Our top 15% are these guys. We're looking for that K value above which we will have 15%. Well, if it's 15% above, that must mean that there's 85% below. And the inverse norm feature on your calculator must be dealing with the percentage below the K value that you're looking for. So we'll go to inverse norm, and we're going to use 0.85. And then our mean is 68 and our standard deviation is 8. and it'll tell you that this K value is approximately 76.3. Now, in order to show my work, I should write down the fact that I'm using the inverse norm, and I used 0.85 because it's 85% is below. You always have to know the percentage below your K value. And so if necessary, subtract it from 100% in order to get the other side. And that's going to give me an answer of 76.3. And I'm done. Number 14. The population of dystopia, 1.47 million people. Retirement age is 65, the mean age is 61. Mean life expectancy is 61. Standard deviation is 9. Alright, what proportion of the population can be expected to live to draw a pension? Well, to draw a pension means that they successfully reach the retirement age of 65. So what we're really talking about then is what is the probability that someone will have made it to at least an age of 65. If we drew sort of a diagram of the situation, then we'd have our normal distribution curve, and we know our mean is at 61. We're trying to figure out how many of these people are 65 or bigger. And so again, because we're looking for a population, we're looking for a percentage, we need to use normal CDF. So anytime you're asked for a probability, a proportion, or a percentage, use normal CDF. Our lower bound, our left-hand side, is 65, comma. Our upper bound, it goes on to infinity, so let's write 1e 99 is the biggest possible value our calculator can handle in the positive direction, and then our mean is 61, and our standard deviation is 9. And that gives us a probability of 0.328. And if you like, you can express this as a percentage, 32.8%. You'll notice I always round to 3 significant figures. So how many pensioners can the government expect to have? Well, if 32.8% of our citizens of dystopia are of retirement age, then we just need to do 32.8 or 0.328 times our 1.47 million people. And so let's work that out. 0.328 multiplied by 1.47 million. Now, let's figure out what 1.47 million is then. So I've got 1 million would be this many. So 1.47 million must be this many. And so I've got 1,470,000. And that will be the total number of pensioners. There'll be about 482,160 pensioners. Let's include the units at the end. And the last question on this review package is number 15. So we've got some engines that are filled by oil. An average of 270 milliliters. The standard deviation is 0.7. They're normally distributed. How much oil will be delivered to a machine that receives 2 standard deviations below the average? So here's our mean, and let's do 2 standard deviations below. We'll subtract 2 of the standard deviations. So that's going to be 270 minus 2 of the standard deviations. Our calculator tells us 270 minus 2 times 0.7, and that means that we've got 268.6. And I should put in my units, which is milliliters. That's how much oil is 2 standard deviations below the average. Now we need to draw a diagram of this normal distribution, which indicates the mean and the increments of standard deviations above and below the mean. Alright, so here's our normal curve. We know that our mean was at 270, and then our standard deviation is going up by a distance of 0.7. So that's going to be 270.7, that's going to be 271.4, that's going to be 272.1, and if we go by 0.7s in the other direction, we'll have 269.3, 268.6, and 267.9. So I've indicated the mean and the increments of the standard deviations above and below the mean, and now I'm supposed to shade the region that represents an amount of oil between 268.9, which is right here, Let's indicate that, 268.9 up to 271.7, which looks to be about here. 271.7. We'll shade that region, and I've done part B. Part C, let's find the percentage of the engines that receive more than 270.7 milliliters of oil without using a calculator. Now this is something that's only in the studies course, and you guys have to know your percentages. In each of these regions is 34.13% in each of these, and then we've got this region is right here, we know is 13.59%, but we're looking for everything above 270.7, so that's going to be this one and going onwards. So 13.59, this one was 2.15%, and this little one out on the far right was 0.13%. So I'm going to have to add these three percentages that represent the areas of the regions to the right of 270.7, more than that. Let's add them together. 13.59 plus 2.15 plus 0.13, and that gives us a total of 15.87%. And lastly, last question. The engines that receive the bottom 6% of oil will not start. So we're talking about the bottom 6%. Let's just change color. The bottom 6%. So that's going to be really quite a small amount, the bottom 6% down here. And so this region right here is only 0.06, or 6% if you prefer to write it as a percentage. We're trying to find out what is this value right here, such that below we have 6%. So because it's already less than, I don't need to do any work. Whenever it's less than, I'm in good shape already. Because they've given me the percentage, I'm going to use the inverse norm. And so inverse norm, and I'll just type in my percentage below my K value is 0.06. And then I've got my mean of 270 and my standard deviation of 0.7. And I find out that this value is about 268.9, which certainly corresponds nicely to my diagram. This was very close to 268.9 already. And so that's the amount of oil required in order for the engine to start. So I should probably just write down inverse norm if I'm showing my work. The inverse norm 0.06 because it's 6% below my K value, and then my mean and my standard deviation. And I got, if I'm going to round to 4 significant figures, it would be 268.9, but of course we can always round to as few as 3 significant figures, and we know that the units is milliliters. And that's the end of your review. Good luck on your test.